Hello, this is Dev Tigris, and you're watching JavaScript HTML5 game development tutorial number 7. The end result of our previous tutorial was these two JavaScript functions. So let's go ahead and type them into our editor. For situations like these, I'm actually going to add a new JavaScript file, and I'm going to call it utility. utility.js, and this is the file that we're going to add into our engine at this location at the very bottom. So I'm going to copy one of the JavaScript libraries that we added before and simply add another one, utility. And this is the file where we will add a whole bunch of different JavaScript functions. I'm going to make the font a little bigger, and I'll simply type the functions in here. I to xy. So this one takes an index and using this index we're going to calculate the xy position on the map. So we have just created a function that takes an index and returns xy. All of this has been explained in my previous tutorial, so you got the theory of this from there. One other thing that stands out so far is the map width, and we actually might want to specify it as one of the arguments for the function that we will pass, because you might have a different size tile map or sprite sheet. By the way, this function can also be used in Spritesheets, as we will see later in this tutorial. But for now, just know that this is following the theory from the previous tutorial. We take the index and return xy position. This is basically the math calculation from most platform and RPG engines. And this is just how it's done. I mean, we discussed the details of these things, but whether you actually understand them or not, it doesn't really matter. But on the other hand, there's really nothing to understand. The modulo operator gets us the x, division and floor operation gets us the y position, all from a single index from the sprite map array. It's very basic, and we need to supply the map width to work with. So it's pretty simple. So let's write the other function. This time xy to I. So this is the reversal. We take xy and map width. And in this function, we simply return this really simple statement, which is, it's simply y times map width. So as you know, to calculate the y, you simply multiply whatever the value is by map width, because that's the number of rows that we'll get. And after that, you simply add x. So this is the basic formula that calculates what we need. It gets the index from xy coordinates. So we got these two functions now that go both ways. And that will be incredibly important, as you will see. And as simple as they are, it's probably usually a good idea to put something like this into a couple of functions so we can use them later. These functions will be used to work with our game world tile map, but also in any sprite sheet grid of whenever there's a array rendered as a square in sprite sheets or in actual game world on our map, on our game level. These are the functions that we're going to use to go back and forth between index-based coordinates and XY on the same square box, which is our tile map world. And another thing I should probably mention is the using of XY, returning XY in brackets. If you're wondering what this means, it basically means that this function will return an array of two values. So later on, once the return value is returned from this function, we can refer to X like this and Y like this. So that X this is simply an array and we're returning it. So at index 0 we'll get the X, index 1 we'll get the Y. So this is just an example, it's not actually part of the function. I now want to introduce you to the next subject of this tutorial, sprite sheets. A sprite sheet is a single PNG picture containing various animation frames for a sprite, or simply different objects for our game. Each sprite is about, it could be 16 by 16 pixels, but in the case that I'm going to be showing you, it is actually 32 by 32. So let's take a look at a basic sprite sheet. This is a very basic PNG sprite sheet of a dog. It's running in different directions. There are 8 directions in total, and each direction has 4 animation frames. It's interesting to notice that the sprite sheet is 8 by 8 squares, and each square is 32 by 32 pixels. This sprite sheet will be available for download together with the entire source code for this whole tutorial. The link will be available in the description of this video or elsewhere on the screen. The next thing I would like you to take a look at is we need to understand that each frame has a correlating index associated with it. And since this is an animation sprite sheet, we also need to have a way to determine the animation sequence in terms of these index values. One of the examples of that would be to have the dog run to the right, and the sequence for that would be 1, 2, 3, 4, and our animation engine will at this point jump back to frame 1 and the entire thing will repeat. But now if we want the dog to run south, we'll simply use the sequence 17, 18, 19, and 20. And these are the values that we will pass as an array into our animation rendering function, as you will see later in this tutorial. Now, having said all of that, before we move forward, let's analyze this in simple terms. Our animation will contain 4 frames, and from the standpoint of JavaScript, we'll have 3 variables here. Frame index, which is the 0, 1, 2, or 4 in this case. We'll refer to these frames. The sequence itself will contain an array of 4 of these index frames. Remember, this is the first index. There's another one, 0, right here, but it's not shown in this animation because the sequence of the dog running right goes from 1 to 4. And that's exactly what will be stored by the sequence array. you can choose any other frame from the sprite sheet to construct your animation. And also you can use as many frames as you want. It's not going to be limited to 4. So in our sprite animation engine, it will be capable of addition of as many frames as you want. Just in this example, we're using 4. And the current frame is the result of frame index applied to the sequence. So for example, frame index is a simple counter. If it's 0, we're going to get frame 1 from the sequence. If it's 1, we're going to get 2, and so on and so forth. So you can see how there are 2 levels of indexing going on. Frame index is just always 0 to whatever the length of the animation is, in this case 4 frames. The sequence is the actual order of frames using the index from the sprite sheet that we have seen in the previous example. And putting these together results in the current frame. Let's take a look at another animation of the dog running down. And this one has different index frames from 17 to 20. And again, the frame index will be just 0 to 4 because it goes from 0 to whatever the length of the entire sequence is. So 0, 1, 2, 3. And plugging that into the sequence array, we're going to get these values. And these are the values that you will see that the current frame is at that particular frame in our game as it's running. Because the frame index is always increasing, once it reaches the last frame, it goes back to the first one again, whatever is in that sequence. And so that's how the current frame is calculated. Now remember that our engine is running at an interval set by this part of our code with the set interval function. And we discussed this earlier. We can change this value. For example, 1000 means to update our game every second. But if we set this to a very low value, it can be 0, 1, or sometimes I use 24 because that's the 24 frames per second, supposedly. And because of this, and the fact that our animated sprites are going to be within this loop, then our sprite animation will also run at this rate, because every time we increment frame index, it's going to happen at this interval that we're setting here. And sometimes, because our game is running so fast according to that value we just set in the previous example for set interval function, for that reason we could use a animation delay. And what I mean by that is that in addition to these 4 JavaScript variables, there's going to be a 4th one, making sure that there's a delay in our animation that makes it look good enough, not too fast and not too slow. And so having said that, I have 4 JavaScript variables responsible for creating our animation function, which is the next step of our tutorial. The sprite sheet index is the sequence itself. Animation delay is a variable used to slow down animations that are seemingly running too fast. Animation index counter, this is basically the frame index that we talked about, and animation current frame is the resulting frame of that sprite that's being animated in the current frame in our game. And now I just realized something. Because the utility function will be used in pretty much, could be used anywhere in our engine, we probably want to add it just right after jQuery, because otherwise these other files would not be able to access that code. as we mentioned in one of our first tutorials, the order in which these components are added matters. And so just make sure that the utility is added pretty much in the first placement so that all of these other JavaScript files have access to it. Now I'm gonna go into Sprite.js file, and before I recorded this tutorial, I already wrote the new function that will draw animated sprite. And what I did was I modified our original sprite object. And the first thing that I did, I added the counters and variables that we have just discussed in our previous slide. So here they are: animation delay, index counter, and the current frame. These are properties of the sprite object, so that means they will be attached to each instance of the sprite object. This also means that every animation has these unique parameters set aside only for itself. And the second thing that I added was the actual draw animated function. And here it is, seen here. And again, I'll go over the basic details briefly and what's happening here. But it's basically doing the same thing that I have just described in the previous slide visually. And this is the code that does that. It basically increases the counter for animation delay, and then it does the calculations to determine which frame is the current one based on all of these counters, animation delays, and finally it pulls the Spritesheet index and retrieves the current animation frame. You can take a look at this source code yourself. There should be a downloadable link for the entire source code for this whole tutorial. And for that reason, I'm not going to type this live in this tutorial because it's already getting a little long. And it's not really that much of a complicated function anyways. The only thing that I can probably adjust here, first, we don't really need this else statement at all. This is just a drawback of something I was experimenting with. And so the entire function can be reduced, in fact, to something like this. And once again, another interesting part that can be adjusted here. Remember how we discussed the x, y to I functions earlier, the ones from the utility JS file. And at this moment, I'm just doing it manually. Spritesheet x equals, so I'm not using those utility functions, but it's probably a good idea to use them here. So what I am going to change about this function live in this tutorial is the usage of those utility functions to help us calculate these parameters. And so the function I'm going to use here is I2xy, because what we want to do is we want to convert the index into xy coordinates. And this function will take our index, which at this point in this function is animation current frame. And it also needs the width of the sprite sheet. And at this moment, it's really hard coded to 8. Let's assign the result variable, whatever we get back from this function. And instead of doing this calculation manually, now we can grab this value from res0 and this one res1. So we are just doing exactly the same thing that we were just doing before, but now we're using this function conveniently. And it just makes the code look a little cleaner. And also notice here that this context draw image function, this is at the core of rendering sprites into the canvas from a sprite sheet. So this function allows us to grab our sprite from the sprite sheet PNG and render it at this position. Notice that everything is multiplied by 32, and that's because our sprites are 32 by 32 pixels within the sprite sheet. If yours are different, you should probably change these numbers around. I'm going to simplify this a little more. So I'm going to take res sprite sheet and plug this in because it's really the same thing. We're just using needlessly more variable names than we really have to. And this will also allow me to do something like this. So what we really end up with at the end of all of these editings is with a really short and convenient function for drawing animated sprites from a PNG sprite sheet as our source image. I think at this point we have enough knowledge in source code to start animating our sprites. So I'm going to go into the main code for our engine, and this is our game loop. So we're going to add sprites just underneath after the step when we have drawn our map on the screen. And in this step, we're going to add some animated characters. Of course, at this stage, we don't have to add animated characters. We can add any character that we would like to draw on top of this tile map. But because this is an animation tutorial, we're going to draw animated sprites. Notice that in this tutorial, I have the dog sprite sheet added to the project, and it has a name of dog-sprite-sheet.png. So in order to load it into our engine with the tools that we have developed so far, we simply can create a new variable dog, and just like in the previous steps for loading any sprite, including the water and the brick wall, we're going to add this sprite sheet and assign it an instance of an object sprite to the variable dog. And in this case, what have just happened here is that we have successfully loaded the sprite sheet into our engine. Now we're going back into our game loop, and here we're actually going to render those animated sprites. Having developed all of this theory and code, it's actually pretty simple at this point. All that we have to do is to go into dog object that has just been loaded, and we're going to use our function that we have just created in the previous step, draw animated. We're going to specify where the dog is going to be animated, which is 64 on x-axis and 32 on the y-axis. And in addition to that, we're going to specify the sequence of the frames. Again, you're already familiar with it. So 1, 2, 3, 4. This is the sequence that has our dog running to the right. And so I'm going to save this and see what happens on the right hand side in the result window. I just refreshed the browser, and as you can see here on this tiny screen, the dog is actually running. So congratulations, we have finally rendered our first animated sprite on top of our RPG rendered map. I'm going to make the code a little bigger so we can see what's going on here. And I'm also going to make this screen a little bigger so we can actually see the sprite. Can we add another sprite? Yeah, sure we can. Let's add another animated dog, and this time add 64 64, and this time our dog will be running down, and as you remember from previous slides, it starts from 17, 18, 19, 20. So this sequence is going to give us the dog running down. So I'm going to save this and refresh the page again. It's interesting that it turned the other dog in that direction as well. And that's because our sprite shares the animation sequence as it's being rendered. So in this case, I think what we could do in our game, we would not really do this in the same way, but we could load the same sprite sheet into the second dog object and use the second dog here instead of using the same object. And this, if we save this and refresh the browser, you will see that we have actually two separate dogs running in two different directions. I think it's a bit too much having to load the sprite twice into two different objects. We could get away with just one, but at this point in our engine, we don't have that code yet, and it's going to be the subject of our next tutorials. Probably one last thing that could be adjusted here is the animation rate. Let's make it 12. Let's refresh the page, and you'll see that the dog is running a little faster. So by changing the values here, we can adjust the rate at which our game is running, and you just have to see it for yourself based on what you're trying to accomplish. We'll get back to a slightly better implementation of sprite animation without having to load the sprite sheet multiple times. This is a pretty good way that we have right now for rendering multiple objects. It's not so bad. It could be improved, but I think this tutorial achieves the intended purpose that was set for it, and we have successfully rendered some animated sprites. And finally, you have an opportunity to help me achieve more tutorials, better tutorials, and you can do that by helping me on patreon.com/devt. It's only $1 minimum, and that's really all there is to it. When enough of people from my audience make donations, it's really helping me to continue doing my work. And in addition, you can follow me on Facebook. This is not my tutorial page. It's more like Tigris Games production and game development news about the projects that I'm actually working on and publishing. So there's concept art, there's all kinds of game related things, everything that is related to game development that I'm usually involved in. So if that kind of thing interests you, please follow me on Facebook. Thank you for watching, guys, and I'll see you in my next tutorial.